Okay, we have talked about domain and range from a table, from ordered pairs, from a mapping, okay? We've also done it from a graph. We have not done it from a graph in the way that we're about to do it right now, and we also have not done it from an equation. So that's what today's lesson is about. We are going to look specifically at a graph that has two arrows. So not just one, but two. Okay, that's something we have not done yet before. We're also going to look at an equation. Okay, and we're going to do the graph first because once we know how to do it from a graph, step one in doing the equation is to graph it. So basically, we're going to do what we did over here, except I'm going to show you how you might use the calculator to get a graph if you don't have one already. So let's start over here with the graph. So I'm just going to cover this side up for a second so that it doesn't look like too much. Okay. So let's say that we have a graph. We notice that this graph is a straight line. We notice that this graph has two arrows, so not just one. I'm going to do the same thing we always have done. We are going to write our ordered pairs at both arrows. So if we look here, and the answers are here, but we're going to talk through them. If I want to know what ordered pair to write with this arrow, I'm starting at 0, 0, and I'm going to the left forever. So that is why this is negative infinity as my x value. Okay, I'm going left forever, and left is negative. Okay, but I'm also going up. Right, so this is going to continue to get higher and higher and higher and higher as it goes left. So that is why this one is a positive infinity for my y value. Okay, so we have negative infinity and positive infinity. Cool. So now we're going to look at this side. Well, I'm going to the right forever. So that is my positive infinity for my x value. But it's also going down as it's going to the right. And so down is negative, so that is negative infinity for my y. Here's the cool thing. If you have double infinities for your x's and double infinities, that should be a y. Sorry about that. Double infinities for your y's. We have this cool math name for that. All real numbers. All real numbers. So if we were to look at our x values specifically, our x values are negative infinity and positive infinity. So I would write negative infinity and then positive infinity. But I have infinities on both sides of my x. So that means every number ever is going to work, no matter what, as long as they're real numbers. And you don't quite know what not real numbers are, so we're going to stick right here with all real numbers. So when I look at my y values, I have positive infinity and negative infinity. So I put the negative infinity over here, remember, because we always do the least, and my positive infinity over here, because that's the greatest. When I have an infinity on both sides, it's called all real numbers, because everything all the way to negative infinity and everything all the way to positive infinity works. Therefore, we say all real numbers. So that is only going to happen if you have arrows on both sides, okay? You will not have an all real numbers if you have a dot on one and an arrow on the other, like we did in the other units, okay? So this only works if you have arrows on both sides. Got it? All right, we'll see if you really got it or not. So what do we do if we have an equation and we don't have a scenario to go with our equation to know if these are tickets or if these are yoga classes? I don't know. So we're going to graph them in our calculator. So I'm going to have my calculator right here. Hold on, I'm going to get rid of that glare. All right, so I'm going to do it on the calculator over here. You can also see a visual of those steps printed for you. So you're going to kind of get to see it two different ways. So the first thing I want, if I have an equation, and this is specifically written in y equals mx plus b. Okay, if it's not written in y equals mx plus b, we want to get it into mx plus b. So we would maybe have to do some solving or moving things. If it's not already in y equals mx plus b, we want to transform our equation so that it does look like y equals mx plus b. But for right now, we do have this, so that's exciting. So our first step is home, which I've done. So I'm on the home screen. New document. So remember, you can use your arrows here, or I could just click the number 1. I like to click the number 1. Don't save. No. And this time we're going to add a graph. So we're going to go down to number 2 and add a graph. So what I notice here is my cursor is right here. So you see it's blinking. That's where it wants me to type. So notice it says f1 of x, right? f1 of x. That is just another way to use function notation. It's letting us know that the 1 stands for this is the first equation that we're typing into the calculator. Otherwise, it's just a normal f of x. So we know from previous learning that f of x is the same thing as y. Okay. So it would be silly for me to come into here and type y equals 2x plus 5 because there's already a y equals. It's already there. So what it tells you is you type your equation in, but do not type in the y because the y is already there. It's looking like f of x. We start after the equal sign. So here's my equal sign. I'm going to start with 2x plus 5. Okay, that's it. 2x plus 5. Then we're going to click enter, enter. Okay, so we look at our graph. My graph is going on forever because it's a straight line. So on your picture here, I put some arrows there for you. But I know that my line is going on forever because I gave it an equation. Okay, your equation, hint, hint, will more than likely go forever if you do not have boundaries set on it by real life. So the only time that an equation that is a linear equation that looks like this is going to have a boundary is if we give it a boundary based on a scenario in real life. Mathematically, there is no boundary. So therefore, if I look towards this side, I'm going to the right to infinity, and I'm going up to infinity. So I have positive infinities. And if I look over here, I'm going to the left, that's negative infinity, and I'm going down, that's negative infinity. So I have negative infinities here. So for my x values, which is this one and this one, I have infinities for both. So my domain is all real numbers. For my y values, I have infinities on both. So my range is also all real numbers. Okay. So here's the deal. This only is true when you go to infinity in both directions. Okay? So let's take a look-see. That's the only piece of new information, but it's not the only thing you're going to practice on. So if we look at our practice, okay, what do we notice about number 1? 2 arrows. Okay? You need to know that. Okay? So follow your steps that you learned on how to do this. You're going to choose a multiple choice answer. You're going to put that answer here, and then you're going to explain using words and or showing work. Okay, but this has to be completed in order for you to earn credit. Okay, we're not just picking a letter and writing a letter. You either show work, like I did, right? Look at all this work I have. Or you write sentences. Okay. So if we look at the next one. Well, this one has no arrows at all. But our process is the same. You write your ordered pair. You write your ordered pair, right? You put the least to greatest. You figure out if it should be underlined or not underlined. Okay? So your practice is a mixed review of all the things. So this one is a scenario. So you're going to have to think about, is it discrete or continuous, right? So remember, F and D are continuous. H and J are discrete. So you're going to have to think about the situation. Remember that continuous means, right, I can have parts, right? Discrete, I can only have whole numbers or specific numbers, right? Like I can only buy a whole ticket, right? I can only invite whole people to my party, right? But we can use parts of gallons of gas, or I can eat parts of cookies. Okay, so think about that. Number 4, this one might have arrows in both sides if we did not have the boundaries of real life constraints. So we are going to go ahead and assume that we have 2 boundary points here. Okay, but if this one did not have a real life scenario, it very well might have arrows going in both directions. But we have set boundaries of time and distance. So we cannot travel negative distance, so this part of the graph wouldn't make sense. I'm sorry, this part of the graph wouldn't make sense, and you cannot have negative time, so this part of the graph wouldn't make sense. Okay, so we have set those boundaries. That's what I was talking about earlier. Number 5, you have an endpoint and an arrow. Okay, so write your ordered pair, set it up. Okay, in case you need this, a reminder for other ones, if you're doing continuous, it looks like that. Okay, if you're doing discrete, you use braces, you list out all your numbers, and you do not repeat any of your numbers. Okay, so if you need to put this in for wherever you're doing some discrete or continuous problems, you may use that. Remember, you have to put your lowest, your greatest, and then you have to decide whether or not these should be underlined. This one, again, we have an endpoint and an arrow, and this one is a scenario. So you'll have to decide what is appropriate for that scenario. You guys got this? Have fun. This is what you would expect the questions on your test to look like. So this is the most important practice of this whole section of domain and range.